Hi, I'm Matt, and in this video we're going to talk about how to use the definition of the derivative to actually compute the derivative of a function. So first off, I'm just going to remind you what the definition of a derivative was. The definition of the derivative says that the derivative of f of x, or f prime of x, is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So again, we're going to use this definition here to compute the derivatives f prime of x. So we should note that if we were to plug in h directly, we would just get f of x minus f of x, or 0 in the numerator, and then a 0 in the denominator, which would be an indeterminate. Therefore, if we were to plug in h directly into our definition of the derivative formula, we would always just get an indeterminate. So when we use the definition of the derivative, we're immediately going to try simplifying it. So on that note, let's talk about how we would actually use the definition to find the derivative. So the first thing we're going to do is plug x plus h into the given function of f of x to compute f of x plus h, because again, we're going to need both of these for the definition. Next, we're going to expand f of x plus h as much as possible. For example, if we end up with a sum in parentheses squared, we're going to want to multiply out the terms, because that will be helpful in simplification. Now we're going to write the definition of the derivative, just write it exactly in this form here, and then plug in f of x plus h and f of x. And then from there, we're going to want to simplify the numerator as much as possible. So that means when we have the function f of x plus h minus f of x, we're going to want to cancel out as many terms as possible there. So we're left with the simplest possible form of the numerator. After that, we want to simplify the fraction as a whole. In the best case scenario, the h from the denominator will completely cancel out with the numerator. And then we're just going to evaluate the limit. Now, I should note here that if you don't get the h in the denominator to cancel out, then you're going to have to use special theorems such as squeeze theorem to determine the value of the limit in step 7. We will not be discussing that in this video. Everything here in this video, you will be able to cancel out the h in the denominator. But I just want to make it known that not everything can be done in this way, and sometimes advanced theorems may be necessary that you might learn in an analysis course. And assuming step 6 and 7 does allow us to get a non-indeterminate or a real number as our answer, then we're just going to write our final answer as f prime of x is our result from step 7, or our derivative is just what we found for the limit. So now let's try an example. So first we have the function f of x is equal to x squared. So the first thing we're going to do is write that f of x is equal to x squared. And now we're going to plug x plus h into this function. And f of x plus h is going to be equal to x plus h squared. But we don't want to leave it like this. We want to multiply out the x plus h times the x plus h to allow cancellation in later steps easier. So when we multiply this out, we're going to get x squared plus 2xh plus h squared. And from there, the next thing we're going to do is write our definition of the derivative. So the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. And again, our derivative, f prime of x, is going to equal this. So now we're going to plug in our two functions, f of x and f of x plus h, to get that the derivative is the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared. And then that's still going to be divided by h. But now we want to simplify the numerator, and what we can do, we see that we have a positive x squared and a minus x squared. So those will cancel out, and we're left with that the derivative is the limit as h approaches 0 of 2xh plus h squared divided by h. So now we're up to that step 6, and here we can cancel out the h in the denominator. So this h would disappear, the denominator h would disappear, and the h squared would just become h. And we're left with the derivative f prime of x is equal to the limit as h approaches 0 of 2x plus h. We're now going to actually plug in the 0 for the limit, which gives us 2x plus 0, which equals 2x. So that will be our final answer, that f prime of x is equal to 2x, or in other words, the derivative of x squared is 2x. Now let's try another example. Let's try 3x plus 4. So we're going to start the same way we did in the previous example. We're going to take f of x is equal to 3x plus 4. We're just going to write that. And then we're going to plug in x plus h. So f of x plus h is going to be equal to 3 times. Be careful that you put the x plus h in parentheses here, and then add 4. Now that we've done that, again, we're going to want to simplify the f of x plus h as much as possible. Here that means multiplying the 3 out into the parentheses. And that will give us that f of x plus h is 3x plus 3h plus 4. And now that we have those two functions, we could write the limit as x approaches 0 of f of x plus h minus f of x all over h is our derivative. Because again, we're always going to want to neatly write our definition as a good starting point. So now we're going to plug in f of x plus h and f of x. So we now have that the derivative is the limit as h approaches 0 of 3x plus 3h plus 4 minus, now when we write the f of x, we want to make sure everything's in parentheses because we want to distribute that negative n. So it will be 3x plus 3h plus 4 minus the quantity of 3x plus 4. And then we still have everything divided by h. So here we see that we have a 3x, and when we distribute the negative n, we're going to have a minus 3x. So this will cancel out. Similarly, we have a plus 4, and when we distribute the minus n, we're going to have a minus 4. So that cancels out. So after cancellation, we're just left with the limit as h approaches 0 of 3h divided by h. And of course our h's will cancel out, and we're left with the limit as h approaches 0 of 3. However, if you've seen my video on limits or you're familiar with limits, you know that the limit of a constant is just the constant. So the limit as h approaches 0 of 3 is just going to be 3. Therefore, we find that f prime of x is equal to 3, or the derivative of 3x plus 4 is 3. And that is our final answer. Now we're going to try one more example. This one, the algebra may be a little trickier, but it's all the same concepts. So, as before, we're going to start out by writing f of x. So we get that f of x is equal to 1 over x. And now we're going to write f of x plus h. F of x plus h, when we plug it in x plus h, is just going to be 1 over x plus h. Here, there's no further simplification we can do for f of x plus h, so we're going to jump directly to writing our definition of the derivative and then plugging into it. So again, here we have our equation for we have our definition of the derivative. And then we're going to plug in f of x plus h and f of x. So we get that our derivative is going to be the limit as h approaches 0 of 1 over x plus h minus 1 over x, all divided by h. So from here, I understand it might look very tricky for where to go from here, but what we're going to want to do is, as we say in the steps, we want to try to simplify the numerator as much as possible. And in this case, what simplifying the numerator means is trying to write this as a singular fraction. So the first thing we're going to want to do is make common denominators. So we're going to multiply our first fraction by x. And then we're going to multiply our second fraction by x plus h divided by x plus h. Because again, that will give us our common denominators. And when we do this, we find that the derivative is going to be the limit as h approaches 0 of x divided by x times x plus h, and then minus x plus h over x plus h times x. And still all divided by h. So now, simplifying further, we're going to write the numerator as a singular fraction. So that will be x minus x plus h divided by x times x plus h all over h. From here, we're then going to move the term in the denominator of the numerator into the denominator of the fraction overall, to get now the limit as h approaches 0 of x minus x plus h divided by x times x plus h times h. So now simplifying the numerator, we'll multiply the negative sign in, and we see that our x's cancel out, and we're left with the limit as h approaches 0 of negative h divided by x times x plus h times h. We see that we could cancel out our h's now, and we get that the derivative will be the limit as h approaches 0 of negative 1 divided by x times x plus h. With our h in the denominator now canceled out, we could plug in h directly to get that the derivative will be equal to negative 1 divided by x times x plus 0, which gives us, finally, negative 1 divided by x squared. And that will be our derivative. So our final answer here is that the derivative of 1 over x, f prime of x, is equal to negative 1 over x squared. So now that we've done these 3 examples, here are 4 practice questions for you to try on your own. The first 2 should be very similar to 2 of the examples I worked through. The third one's also very similar, however, I will warn you, the third question, the algebra, may get a little messy. If you know Pascal's triangle, that can be very helpful in multiplying out your binomial. And then for the last question, the simplification can get a little tricky. So I would try these 4 on your own, but if you need a hint on problem 4, a hint will appear in 3 seconds. Okay, so if you're having trouble with problem 4 after getting your fraction, I'm going to suggest that you look at using the conjugate, because when you have radicals, the conjugates are often helpful to simplify. So with that now, the answers to these 4 questions will appear in 5 seconds. Okay, the answer to the first question was that the derivative is 8x. For problem 2, the derivative was negative 1 divided by x plus 2 squared. For problem 3, the derivative was 3x squared. And for the problem 4, the derivative was 1 over 2 square root x. I hope you got these. If not, feel free to leave any questions you have about this video or derivatives in general in the comments below. Thank you so much for watching. Have a great day.